If you want to understand why we built a private network, here is the simple idea. In cold chain supply network, multiple organizations handle the same shipment, the manufacturer, transporter, retailer, and regulator. The problem is that each organization can have its own system and records. So when something goes wrong, it becomes difficult to establish one trusted history of who handled the shipment, where it went, and whether it stayed within the required temperature range. ColdTrust solves this by connecting these organizations through one permission network. The manufacturer creates a shipment, defines its temperature range, for example 2 to 4 degrees Celsius. The transporter accepts custody and the shipment journey continues. During transportation, sensor telemetry records temperature, humidity, location, and time. Now imagine the temperature reaches 5.2 degrees Celsius. ColdTrust smart contracts automatically compares the reading against the shipment limit. 5.2 is greater than 4. The shipment is marked compromise. The event becomes part of the shared audit history. The manufacturer can verify what it shipped. The transporter can prove how it handled the shipment. The retailer can verify its condition before receiving it. And the regulator can independently audit the entire journey. Behind this, a four-organization hyperledger consortium network where an authorized participant shared a trusted ledger while maintaining controlled organization access. The goal isn't blockchain for the sake of blockchain. It is about creating a trust infrastructure where traceability, custody, and compliance become part of the supply chain. This is cold trust, trusted infrastructure for the cold chain. And if you want to understand the blockchain technologies behind it, that's a story for another video. So let's see how our application works. So whenever we need to create a private network, we have to start with creating the Genesis block. Here order or org is the Genesis block where we'll have the rules. As it is a private network, we'll be enforcing some rules who all are can be the peers in the network and their port numbers and consensus policy, channel policies. We'll mention everything in this Genesis block. Then we'll add the peers in the network. So let's see how the application works. So let's start all the containers we have. Scripts network dot sh. Now let's create the channels. Six, eight. Now let's deploy the chain codes into it. Now let's start the backend if it finishes. Start our front end now. Let's start our simulators. Network it is sending the telemetry data, right? Now active in transit to stimulate. Okay. Let's see how our network works. Here you can see all four peers, all the four nodes in our network. Let's say a manufacturer created some medicine, he produced some medicine, he'll name it, he'll give it an ID, then he'll say where manufactured, and we'll be giving it some threshold based on the medicine and we'll be committing the asset. Let's say the threshold is up to 4 and we'll commit the asset. So now all other peers in the network can audit this transaction, like where is it, what's the temperature, everything. Here, since the transporter didn't take the medicine, there is no movement, but still we'll get the data from the stimulators that are running in the backside and the place where it is. So now let's say the transporter accepted the medicine. There are multiple HTTP requests going backside, that's why there is an error. So the transporter accepted the consignment. Now here the pharmacy, the retailer MSP can see whether it got compromised, and if it is compromised, he can reject the medicine as well. Here you can see the graph where it reached how much temperature, and also every second they'll be getting this data from the backend ledger. If it is compromised, he can reject, or as it is following threshold, he can confirm and receive the delivery. So regulator MSP is like a government who is monitoring all these things. Even when some medicine is compromised and still used by someone, it's like a proof that there is a compromised medicine is used and they can put some legal actions on them. So this is how our network works. Let's see how. So now here you can see HTTP get post requests are almost going every time. Like it is getting the data from the stimulators. Here you can see our stimulator is producing data every second. So this will be taken by our backend. And also when we create some consignment, it will take those data with the post. So that's why we got an error when these two requests collide each other, we're getting some error. Maybe we can find the error here. Here you can see transaction failed to commit with status. See here you can see conflict. Because of a conflict it couldn't happen. So that's all for this video. This is how our application works. If you want to know about blockchain or if you want a detailed video working with this Hyperledger Fabric, you can slide into my DMs and let me know.